Hello, everyone. Welcome to Concordia University's fourth space, and thank you for joining us for the next installment in our Closer Look series, looking behind closed doors into spaces and projects that you might not know about at Concordia. And today, we're taking a closer look at the School of Health Sleep Lab and the Multimodal Functional Imaging Laboratory work that's happening currently here at the School of Health. Now, to help situate you, first, we are streaming to YouTube, live from Concordia, and we are located here on unceded Indigenous lands in Chichage, Montreal. And just a note of caution, we're hosting this as a live streamed event here in the space and on location on the Loyola campus. So things can happen, video and connectivity issues, they're expected. That's part of the fun. Just stick with us as we show you around. We're also running this as a Zoom meeting. So anyone joining us via Zoom, if you have any comments, questions, just pop those into the chat and we can do our best to read those out a little bit later. Okay, now just to kind of give us we're happy to pass the microphone and even the camera over to Professor in Physics, Dr. Christophe Grova. Christophe, how are you doing?
Very well, thanks.
Where are we?
So we are at Concordia. We are on Loyola campus, and right now we are at one main building of the School of Health, which is called the Perform Center. The idea of that center is it's equipped with several platforms that is dedicated to study brain health, and we are looking in different aspects of lifestyle, including exercise, nutrition, and sleep. I'm more expert in sleep and multimodal imaging, and that's what we're gonna show up today. So, okay. I'm a professor in physics, and I'm an expert in combining different imaging devices to study the brain, and we're gonna show it today how this can be used to study your brain when you sleep.
Fantastic. All right, let's go on in.
Okay, so let's move in. So I welcome you to the lab.
Nice.
Okay.
Hello, everyone.
So we have a bunch of people here. We have our nice participants, Edouard and Rasheda and Mathilde, who are researchers.
Mathilde, Edouard. Nice to see you down here in fourth space. It seems to be some. So what's going on, Christophe? Can I give us a little walkthrough?
Yeah, I will explain you the more details, the project.
Yeah.
So you are here in a sleep lab. So you'll see in a moment that it's equipped with very nice room to sleep. It's headed by another professor here, Dr. Deng Vu, who's an expert also in sleep at Concordia University. And the standard way to study sleep is through what we call electroencephalography. So you put electrode on the head, like Edouard has for the moment, and you record electric activity. When your neurons are active, they generate electric signals. And we know that when you sleep in your different sleep stage, probably you have heard about light sleep, deep sleep, REM sleep, which is more or less when you dream. And that's what you can detect using the electricity signal. This is the standard way to study. And with that, you can diagnose different sleep disorders. In my research, we also study the interaction between sleep and epilepsy and so on. This is the standard way. Here, we wanted to bring something new. We wanted to shine light on the brain of Edouard. We wanted to use a technique that is called near-infrared spectroscopy. So probably most of you have heard, if you go in ER or something, you put a little stuff on your finger to measure the oxygenation. And the idea is like that. I'm using my cell phone. So you see, if you put light on your finger, the light does not go through directly. It's going to scatter in all directions. So what we have installed on the head of Edouard is a bunch of laser light sources and detectors, so that when the light goes through his brain, the light will be sent on one electrode. It will diffuse as a banana shape and reach another one. So if this part of the brain is active and consume oxygen, this is something we'll be able to measure. And this
Edouard,
is the new, yeah, sorry.
I was just going to say that looks really comfortable for sleeping in it.
Actually, we sleep quite well with it.
Okay.
Yeah, I just wanted to say we sleep quite well.
Yeah, that's the reason, like, I can talk of it at the end. There are new systems called, this technique is called FNIRS, functional near-infrared spectroscopy. And there are new devices now that are completely wireless, that are very nice and elegant. You can play piano, you can run while recording NIRS, but for the moment, the sensors are too thick. So to sleep on it, it's too much. So that's why for the moment, we are installing the sensor on the head of the participant, which are low-profile sensors, fibers, and we have been gluing them so that they stick there during the whole night, and we get good signal. But we hope that in the future, we'll be able to use next generation of those wireless devices. That's in our plan. We are discussing with the companies, but it's not there yet.
Okay.
So I can show you, I will leave to Rasheda to explain how we can, so this is one fiber, for instance.
Hi, Rasheda.
Hi. So this is an example of one of the sensors that we use for the NIRS.
Okay.
I'm going to
What's the
quickly
adhesive?
walk you through. Sorry?
What is the adhesive? How are you attaching the sensors?
So we use a glue called collodion. It's a liquid glue, and we air it to dry it quickly. And we use a gauze to basically glue the gauze together with the optodes. So you can see over here, this is one of the NIRS optodes, and we have put a gauze, and we use the glue, and we air it and dry it quickly, and it's stuck there very, very neatly. And we can also remove them using a remover, which is like a nail polish remover, you can say.
But it takes time to prepare.
Yes, it does take some time. So we try to cover like 4 different locations on the head, and when we try to install these, it takes some time. Yeah.
Okay.
So I'm going to quickly also show you how we translate these sensor locations with what's there on the computer. So here you can see on the screen, this is basically the reconstructed skin of the subject from his MRI. And we can basically look at his scalp. And using this system over here that you can see, it's a 3D neuronavigation system. And we have this pen here with a goggle here. We can basically locate the motion of this pen based on some landmarks that we mark on the face. And with this, you can see when I try to locate this location on the head of the subject, you can see the same pen directly on the computer as well. So this way we know exactly where we have placed our optodes and the electrodes. This is basically how we co-register all the electrodes position on the head surface once we glue them.
Wow.
So now we are going to move forward, and we are going to place the subject in the sleep room, and then we'll show you how we record the data.
Okay, great.
So they're gonna do the installation. I just want to mention that the reason why we did this neuronavigation is because we were optimizing where are the brain region I want to study. And we develop algorithms that are saying, if you want to study this frontal region or this parietal region, you should place your source like that and your detector like that. And that's exactly what was there on the screen. And with that system, we knew it was there, and we were able to glue it specifically on the anatomy.
Christophe, how specific is that to the person? Does Eduardo have a very specific location compared to someone else's? My head?
For the moment, the beginning of that study is to study the healthy sleep. So we decided to cover mainly frontal and parietal regions.
Yep.
And so now Edouard is getting installed in the bed. So we were hoping to get those regions and those regions.
Yep.
But to be very specific, what we do is we acquire a specific model of the head of the subject. And to do that, we do MRI, magnetic resonance imaging. And we are very lucky that we have an MRI device. We don't need to go at the hospital. We have one right there in the basement at Perform.
Yes, yes.
2 days before, when we do the computations, Edouard got an MRI, and all the preparation where we should put the sensors was placed there.
That gives you a map of where they should be placed.
Yeah.
Okay.
So now Mathilde is setting up the installation. So we have 2 devices here. So this is so the device that is the big white device over there is the NIRS device. So this is where you have the laser source and the detectors that are attached to the head of Edouard.
Right.
And on the other hand, on the other side here, you have another which is quite standard. This is what we call an EEG amplifier. So all of these wires are little electrodes. So this is to measure the electricity coming out of the brain of Edouard. And over there is to measure the optical signal, so the hemodynamic signal. So how much the blood is bringing oxygen to this and that region.
Yeah, okay.
So now, Edouard, I guess you can get relaxed. We're going to set you to sleep.
Relaxed,
not for the whole night. We'll see him a bit later. So
and
we're going to...
It looks like you can't, Christophe, Edouard too, like looks like you can't really move very much when you're in the bed. You have to take some precautions.
It's quite okay to move, and even during the night, you can be on one side or the other, and
okay.
It's okay. It's okay.
The sensor remain attached to his head. So even if he's moving, it's like, that's the reason why for the moment we cannot use the standard cap. They are too thick. And if you move too much, you're going to lose the signal quality. Here we don't lose the signal quality.
That's what you get from the adhesive and Rasheda's careful placement. It stays. Got it. Okay. Okay.
Okay, so I think now that it's set up for sleep, I'm going to check whether it's recorded.
Right, turn off the lights.
Work. And we can turn off the lights.
Good night, Eduardo. Sweet dreams.
Okay, bye-bye. Going well?
Okay.
So we need a few more minutes. It's live.
Okay, we're live. Amazing.
So Edouard, if you can relax, or if I don't know if you So here you see the typical EEG signal from Edouard.
Okay.
And what you see notably here on his occipital electrode, which is back of the head, you see some rhythm around 10 oscillations per second, which is called the alpha rhythm. So that means he's not sleeping yet, but he's getting relaxed. And so this is the way when he's going to start sleeping, we're going to get more and more typical brain activity, like slow rhythm, slow activity.
Okay. And then you record all night.
Sorry?
You record like through a long period of time, all night long.
Yeah, we record. Usually they set up around 10, 11-ish, and they try to sleep 7 to 8 hours of recording.
Okay.
So these are very long recording that we handle.
Yeah.
So this is the classical way, and here that's more the new aspect of it. And this is the FNIR signal. So we don't see much here. We have a laser measuring at 2 different wavelengths. And the main thing that you see, I told you about oxygenation. You see those little waves here, pop, pop, pop. This is mainly your heartbeat. So good news, he's alive. And then, of course, because it's a very slow signal, we're talking about the blood signal. So we don't see very much here. It's not as clear as the EEG, but we are trying to collect much more information there than we will try to study. Okay.
Amazing. Christophe, you need student volunteers. How do you find like subjects to go through this whole process? Maybe.
I will leave to Rasheda to explain that, because
that's
she's
Rasheda
the master of doing that. That's it's really a very large team. So
yes, so we have a good group of team where we have some students who volunteer to help with these kind of process, where we advertise about our studies in the different, student association groups and on different websites. And we have them contact us, and we go through a tele-screening form to see if they're eligible for our study.
Right.
And then there are several different types of tests that we do. We do the MRI, like we need that. We also do a polysomnography study to first figure out if their sleep data is actually good or not. And then we move forward with these FNIRS and the EEG acquisitions.
There's multiple
steps. Have a good turnout. Yeah, we have a good turnover.
Okay. You're not at all problem getting people to volunteer. They know what they're getting into.
Yes.
And is it just is it just for one night, or is it multiple times? How does it work?
Thank you for the transition. It's perfect. So for my project, I'm focusing on memory consolidation, and we ask our participants to come for a second night. So we know that sleep is really important for physical health and brain functions, and especially memory. Research studies have shown that sleep supports memory, that helps to store memory and organize memories. We also know that after a good night of sleep, people remember the information learned during the day better than after a bad night of sleep. And we would like, so for now, to assess specific brain region, we use MRI, but it's really difficult to sleep in an MRI, and also recordings are often limited to a few hours instead of a full night. So with this protocol, which combine both FNIRS and EEG, we hope to assess sleep-related changes and the association with memory consolidation. So during the second night, we ask our participants to perform a memory task during which they learned word pairs. We ask them to remember these pairs of words. We test their memory the evening, but also the next morning to see the process of memory consolidations.
Okay. So there's like a quiz when they wake up.
Exactly.
And if they sleep well, they're going to succeed in the quiz. That's the idea.
Okay.
Okay. I can show you one more. It will look like it's live, but it's not really live because it takes a lot of processing. But this is the kind of things we do from the signals we are measuring here. So here again, this is your signals that you get, but it's not few seconds. Now you see 10 minutes. And this is what we call N2 sleep. So this is deep sleep. And here you have your EEG channels that are showing typical patterns occurring during your EEG. And what we've been doing here is we reconstruct the change of hemodynamic signals along the brain. So this is, we go from scalp recording to activity. So here you see HBO, which means oxyhemoglobin, and deoxyhemoglobin that is fluctuating. I must say that this project is handled by Shala Bakian-Dogahe, who's one of the main PhD involved in that project, who unfortunately cannot be here today. And the software, the implementation of the method, and there is a software package called Nearstorm doing that. That's our nice participant sleeping right now. This is Edouard who developed those.
So maybe we could wake Edouard up and ask him a few questions about that, do you think?
Do a time lapse. Now it's morning.
Edouard, wakey, wakey.
Crossfade. Oh.
How was the night?
Good morning.
Good morning. I had a nice, good nap.
Do you wake them up, or you have to generally, or do you just people? You're there in the morning. If we wake,
yeah, usually we wake them up. We usually ask them what time they usually wake up, and we try to match that so they wake up almost naturally. And
that's reasonable. Okay. And now?
We were talking a little bit about the software
Yes.
that we were just looking at outside, Edouard, and that we understand that you had part in that. Do you want to maybe talk about it a little bit?
Present a bit what you did.
Okay,
what
so
you brainstorm and what you did.
So basically, the main thing that is of interest in our lab is to be able to measure the neuronal and the aerodynamic activity, so EEG and NIRS. So we did a lot of development to be able to visualize and have both activity at the same time, so we can analyze one signal and the other and be able to look at how one will correlate to the other. So how the EEG activity will influence it, aerodynamic and vice versa, and a lot of things like that.
I will just mention that the software I mentioned that I showed you is called Nearstorm, which is really what Edouard developed. But this is a plugin above a bigger software that is called Brainstorm. Brainstorm is not us. It's an international team mainly led by Professor Baillet and colleagues at McGill University. So they are not far from us. And it's a widely used tool to study electricity and magnetic activity. So the EEG I showed you at the beginning, and the FNIRS part of that software, that's really what Edouard developed.
One question we like to ask, though, in these tours and to kind of seeing people working in there, is kind of what brought you into this type of research. I know that we have all the four of you there, but I don't know if we could start with Edouard. What was how did you what attracted you or brought you into this type of work?
So me, I have an engineering background from France. So and in my engineering school, it was mainly focused about how to process signal, and then I wanted to have a nice application, and I thought, oh, studying the brain is very interesting, and then that's how I discovered the lab of Dr. Grova and the application of how we can use FNIRS and EEG to study the brain signal and how the brain is functioning.
Great. Rasheda?
Yes. So I'm Christophe's very first student. I did my master's and PhD with him. Worked a lot on this kind of analysis, but not really FNIRS that time. I was doing some EEG with another technology called magnetoencephalography. And I was involved in a lot of the algorithm design of whatever the techniques that we are using in our lab. Okay. Now, after finishing my postdoc in another place, I'm back again, joined the lab to learn more about this specific kind of the new projects that Christophe is doing. They're very interesting. So that's how I got involved with Christophe's lab and this kind of studies.
Okay, great. Thanks. Mathilde?
For me, I have more background in biology and neuropsychology. During my PhD, I assessed the association between sleep and brain functions. So still in the same research topic with a memory consolidation. I did only MRI and EEG during my PhD, so I'm happy here to learn everything about FNIRS, and I think it's really nice application, and it's the only way for now that I know to study the whole night of sleep. So I'm really happy to join this lab.
Great, thank you. Christophe, I got to know, how did you get into this?
Hola. It's a long story. Actually, most of my work started in the field of epilepsy. I got really trained in I'm a biomedical engineer by training, did my PhD in France, arrived at the Montreal Neurological Institute for my postdoc to work with Dr. Gottman to get trained on what is an EEG signal. Yeah. And the first things we did is we were recording activity from the scalp, so electric or with Rasheda magnetic activity, and we were trying to inverse the problem to find out the activity in the brain from the electric signal. And what NIRS why NIRS bring me there is because NIRS is another signal which is now following the blood, but it's also from the scalp. So the same methodology to reconstruct the map we just seen in 3D are used. And I must say, when we do the reconstruction I was just showing, it's not just 10 minutes. We are actually reconstructing all 8 hours of recording.
The whole sleep cycle. Yeah. Okay. Wow. That's amazing. Thank you. Thank you. It's really great to hear the kind of the backstory of how this happened. I know there were some people joining us via Zoom, Jax. I don't know if there's any questions there. Does anyone have any questions? They could pop them into the chat. But if not, I'll give them people a minute to do so. I definitely want to say thank you. We're going to wrap things up here on our end, but it's been amazing to be able to actually just see. I've seen some people gathering here at the door watching, some people walking by or seeing in here also, and it's really nice. Thank you for taking the time to show us around the lab, and also thank you to Melody, if you're there, for helping us coordinate all of this. We're going to be closing up the live stream now, but this does remain available on our YouTube channel, so you should revisit it and you should share it. And we're also going to make a version, an edit of it that shows on our screens in the evening sometimes, just a visual look inside the lab. So thanks again to everyone for joining us, and have a great afternoon.
Thank
Bye.
you.
Thank you.
Thanks for organizing that.